In example 6, we're looking to find the missing bound on the standard normal curve when given a one-tail curve. By one-tail, what we mean is if we're dealing with a left-tail standard normal, that means that the entire area is on the left tail. This area we give a name, and that's alpha. Okay. Similarly, if we're dealing with the right tail standard normal, then the entire area is on the right. And once again, this area we give it a name and call it alpha. In example 6, they're giving these areas 20% in the tail for example A and B. And what they're asking us to find is they're asking us to find missing bounds z and negative z. So if you consider the standard normal, we're centered around 0. And once again, think about the horizontal axis like a number line. Then in the first left tail, this missing bound should be a negative number. It should be a negative number associated with that bound. And on the other, if the missing bound is on the right side of the number line from the 0, we should expect this to be a positive number. So in example 6, when we're looking at example A says, let alpha be 0.20 and find positive z. Okay. So for positive z, the alpha has to be on the right tail, okay, where the alpha is 20%. This being a positive z value that we don't know at the moment what it's equal to, but we do know the area is on the right tail. So given that we're centered at 0, we should expect that missing bound to be a positive number. So in the calculator, this z is equal to inverse norm. Okay, and remember that we need 3 entries. We need area to the left, the mean, and the standard deviation. And we just said area to the left, but if you note, this tail is an area to the right. So what will happen is the calculator, it will give us a negative answer because a negative answer would mean that the bound is on the left side. So by symmetry, we're going to use the area. Okay, even though it's not an area to the left, the calculator will give us an answer. But what we need to do is determine whether our answer in the calculator should be positive or negative for our curve. Okay, so when we go to second bars, number 3, let's go ahead and input area at 20%, mean standard deviation. Okay, and what you'll notice is the calculator gives you a number, right? But once again, if we're treating this like a number line, our missing bound should be positive. So by symmetry, our z will equal to the positive of the calculator, 0.842. For example B, okay, for example B, we're looking for minus z. That means find the missing bound on the left-hand side of the standard normal curve. So this is my standard normal. Minus z would have to be on this side of the number line in order for us to get a negative number. And we're dealing with the alpha on this tail. Okay, so the alpha here is 0.20. Well, to find missing bounds, the setup is inverse norm. So this missing bound is equal to inverse norm. And again, what we'll do is we'll input the area given, 0.20, mean, and standard deviation, and we'll determine the sign at the end. Okay, the calculator, it's limited in what the sign tells us. We need to interpret what the sign should be. In the previous example, although we got negative as our answer, we determined that we needed by symmetry, it's positive number, right? Because we're on this side of the number line. So the calculator will give us a number here as well, and we need to determine whether we should be negative or positive. So we'll repeat the steps just to see it again. So we go to second bars. We'll go to number 3. Area 20%, standardized normal 0, 1. Okay, and again, the calculator will give us a number. We need to determine, though, if our answer should be negative or positive. And once again, if we're missing the bound on the left-hand side of the number line, we should expect our answers to be negative. So in this case, the calculator was correct. Okay, in this case, the calculator was correct. But again, when you use the inverse norm command for the standardized normal curve, go ahead and input the area that you're given. If it's 20%, go ahead and proceed by placing 20% in the area. But at the end, I want you to determine, should your answer be the negative that the calculator gave or a positive, depending on where you drew the missing bound. Okay.